Alright, we're continuing our AP Chemistry Summer Homework Answer Key. This is Chapter 3, Questions 2 and 3. We're going to work through both of those in this video since they're related. So they're both related. Question 2 and 3 deal with this situation. You're reacting chemical A with chemical B to make one product. That's an important detail. There's only one product that comes out of this. 100 grams of A react completely with 20 grams of B. That 2 there is kind of just a typo. We don't need that. So 100 grams of A react completely with 20 grams of B. What's the complete mass of the product? Well, if we only have one product, it sounds like a stoichiometry problem. It sounds like we got to think through limiting reactants and then calculate it and all that, and we don't have enough information. But this isn't actually a limiting reactant problem. It's just telling us we've got only one product. So this is actually related to the law of conservation of mass. Assuming this reaction goes to completion, we can say chemical A and chemical B to react to produce one product. We can just add up their masses. 100 grams of A, 20 grams of B. They make one product. They react completely. That tells us that because of the law of conservation of mass, we will get exactly 120 grams of our product. And that's the explanation that you would put down here. Because of the law of conservation of mass, matter can neither be created nor destroyed. If we start with 100 grams of A, 20 grams of B, they react completely to form only one product, then we know the product will have a mass equal to their combined mass, which is exactly 120 grams. At least to the number of sig figs that we have in the problem. All right, what's true about the chemical properties of the product? A, the properties are more like chemical A. B, the properties are more like chemical B. C, the properties are an average of those of chemical A and chemical B. D, the properties are not necessarily like either chemical A or chemical B. Or E, the properties are more like chemical A or more like chemical B, but more information is needed. That's a lot of options, a lot of words being thrown around there. But let's think about this situation we just talked about. It says that they react. They react. So it sounds like a chemical reaction to me. Now remember, chemical changes are different than physical changes in some fundamental ways. And one of the biggest ways that we know that chemical reactions are different is their properties are not necessarily conserved. They're not necessarily even similar to the properties of the different elements that are in them. They're not necessarily similar to any compound that reacts to produce those chemicals. An example of that would be hydrogen and oxygen. Hydrogen and oxygen are both gases. Hydrogen is extremely flammable, even explosive, and oxygen supports combustion. But when you put those together and you do a chemical reaction, it produces water, which puts out fire, and it's needed in order to even sustain life. Okay, so very different properties. Those properties of water are not actually that similar to either hydrogen or oxygen. They're very different. So the correct answer for this question is the properties are not necessarily like either chemical A or chemical B. It's almost impossible to predict what their properties are like without more information. And we don't even know if they're going to be similar to either of them. They might be different from both. So the justification that you put down here is that this is a chemical change. And in a chemical change, the properties that make up a compound are not necessarily similar to the properties of the elements in the compound.